All right, let's talk about question W4. W4 gives us a table with a whole lot of information, but it's information about f prime, and f double prime for a function f on an interval that's closed on one end, open on the other. All right, so the big thing to realize is because there just seems to be so much information in this table. One thing that will help is realize that really we've got the left endpoint, the right endpoint, and then really just three interior points on the interval that we have to worry about. So it looks like it's a huge amount of information. It's not really that bad. So let's start with part A. Part A asks for any local extrema, any local maxes and mins, and if we find any, we want to classify them as maxes or mins and justify your answer. This sounds very much like either a first or a second derivative test type of problem. So I'm going to think about the first derivative test, and I'm going to think about where does the sign of f prime change. So f prime is positive, positive. Well, it's 0 here, but f prime doesn't change sign across that critical number. 1 is, again, a critical number for f because it's a place where the first derivative is 0. So that's not, that's a critical number, but it's not a location of a relative max or a relative min because the first derivative doesn't change sign. Here's another critical number because this first derivative is not defined there. And yes, the first derivative does change sign across x equal 2. It changes from positive to negative. When the first derivative changes from positive to negative across a critical number, that means we have a relative maximum. So there's a relative maximum there because because f prime changes sign across x equal 2. And yeah, okay, so, and then finally over here, there's the, well, that's not a critical number because f prime isn't equal to 0, so we don't have to even consider that. There's only one place where f prime changes sign, and that's across x equal 2. What do they say? Pretty much that's what they say. Part B is sort of challenging. They want us to come up with a graph sort of out of thin air between 0 and 4 of f. What does f look like? So the best way to do this, I think, is to separate these things into little subintervals. So I want to think about, first of all, what's going on with f between 0 and 1? Well, first of all, I know where it starts, so it starts at -1. That's why that point is there. And it ends at 0, so that's why that point is there. So the question is now, how do I connect those 2 points? What kind of a shape does it have to have? Well, first of all, because f prime is positive that whole way, that means f is increasing between 0 and 1. And secondly, because f prime is negative, that means f is concave down on that interval. So I have to connect this point with this point through a graph that is both increasing and concave down. And so your graph has to have sort of that general shape, that kind of increasing and that kind of concavity. And that's how we're going to progress through each of these different subintervals. So now I'm going to go from 1 to 2. So right in between here. What's going on? Well, I know where it starts, right? It starts at 0 and it ends at 2, so that's why those 2 points are there. And, well, the first derivative is still positive, but now the second derivative is positive as well. So this graph has to be increasing because the first derivative is positive, and it has to be concave up because the second derivative is positive on that subinterval. Let's keep going. From 2 to 3, I get the endpoints off of the f line, and now I look at this. I have to connect the endpoints with a graph that is decreasing and concave down. There we go, decreasing and concave down. The last subinterval should be decreasing and concave up. You see how this is kind of bending so that the concave part is upward. Wow, that's terrible. But all right, so part B is a challenge. Let's go on to part C. Part C, here's where we're going to have another fundamental theorem of calculus question. They give us G, which is an area function built on F. So find all values at where G has a relative extremum, where G has a relative max or min. Here's the key to this, guys. If they tell you that G is this area function, that means G prime, take the derivative of both sides of this equation, G prime is F. So this line right here tells me G prime information. How do I tell where how do I tell where G has a relative max or a relative min? I look at G prime. Where is G prime changing sign? Another way to say it, where is F changing sign? It changes sign at 0, and it goes from negative to positive, and by it I mean G prime. So G prime goes from negative to positive. That means G goes from decreasing to increasing. That means at 0 there is a relative min. F also changes sign across x equal 3. Notice it doesn't do it across x equal 2. F is positive and stays positive. But across x equal 3, F changes from positive to negative. That means G prime changes from positive to negative. G changes from increasing to decreasing. G has a maximum. G looks like that across x equal 3. So again, you're using the first derivative test to justify your answer. Let's see what they said. They said essentially the same thing. You got a point for concluding that G prime is F. You get a point for noticing the critical points, or the critical numbers, and then you get a point with answers and justifications. Finally, they ask us about points of inflection for G. So now we continue on this. If F is the first derivative of G, then F prime is the second derivative of G. And an inflection point for a function is where its second derivative changes sign. For a function, an inflection point is where the function itself changes from concave up to concave down, or vice versa. In other words, again, it's where the second derivative changes sign. And since G is the area function of F, F prime is G double prime. Where does this line change sign? Not there, positive to positive, but there it does, from positive to negative, and it doesn't there. So the only place where G has an inflection point is at x equal 2, because G double prime, which equals F prime, changes sign there. What do you think of their explanation? Not too bad. Okay, that is W4. Thanks.